Hello, everyone. This is John Jenkins, and um, I would like to bring you another video, the next video in the series about infinity and why infinity does not exist, cannot be used to solve math problems, and this was a back and forth conversation I had with somebody on a TED Ed video. The name of the video was the Infinite Hotel Paradox, and basically, they said if you had an infinite hotel with an infinite number of tenants, how would you make room for 50 more tenants? And that was the idea of the problem, and like with a lot of paradoxes, it's sort of uh, uh, saying something confusing that that can't be answered easily, and you think it's a paradox, but that's not actually a paradox. And in this case, it's just really a fallacy. Uh, you know, uh, Something that cannot be solved because the reasoning behind the arguments is faulty. And I talked about the first part, and I replied to the other person in the discussion, and basically he used a trick that I used to fall for, that I used to believe was true. And basically he said that uh, uh, he said that if you give me a number, no matter, it could be a Google, I could say one Google, which is 1 times 10 to the 100 to the 100th power. You know, I can give you one Google, and then you could say, okay, a Google and one, and therefore, and therefore, and therefore, and therefore, um, infinity exists, because no matter what number you give me, I can give you one. I can add one to it, and that'll be the next highest number. And if it goes past 10, you move the first number over one, and then you add a zero, and that's the next power of 10. So, basically, if I say a Google times a Google, which is, 1 times 10 to the 100 to the 100, you know, uh, I mean, uh, uh, no, that would be 1 times 10 to the 100 times 10 to the 100. Yeah. Uh, uh, so, basically, if I say a Google times a Google, you can say a Google times a Google plus one, and this can go on forever. And also, he said, uh, yeah, also he said, I can, you know, also he said, I can use a computer, and the computer can continue counting, presumably forever. Or maybe I added the part about the computer, but basically his point was that no matter what number I give him, he can give me one more. He can just add one, and that and in effect that's supposedly infinity, but that doesn't qualify as infinity. basically, there's there's a there's a there's nothing that exists. If you watch my first video, there's nothing that exists that is infinite. You know, and I'll get to the reason for that at the end of the video series. But nothing exists that's infinite, and this is the perfect example. For example, if you were to, if I gave you the number one, and then you say, okay, I'm gonna add one to that, so it's number two, and then I say number three, which is two plus one, and then you say, oh, number four, which is three plus one, and basically, uh, basically, you know, if we did that, uh, uh, to the end of from now to the end to the end from now to the day we die, from now to until un- until until we're the age of until we're on our deathbed, basically, you know, you know, from our last breath, you know, if we were to count up one with our last breath, you know, that would be the end uh, 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 of, of, of that count. Basically, if we were to count up one number every second, and the what I did with the calculator, I said, if you count up one number every second, from the day that you're born to 120 years old, counting out one number every second, what number would you arrive at? Now that's a very hard question to answer without a calculator. Basically, the answer is 1,500,000,000, basically, and so that doesn't even take into account two things. First of all, no one is born knowing how to count. You had basically, I learned how to count when I was 5, uh, uh, or maybe a little younger than that. But basically, um, you're not born learning to count, so you got to subtract 5 years from that 120 years, and um, on top of that, uh, the larger the number gets, the long, basically you cannot count, 1,000,000, 115,320,241. You can't count that in 1 second. So as time goes on, you're going to need more time to count every number. You're going to need more time. You're going to need 5 seconds, 10 seconds. Maybe not 20 seconds, but you'll need more than 1 second for every number. So that reduces the maximum number of numbers that you can count by even more. So you gotta take time off from the front, from the beginning, the first 5 years to learn how to count. Then you have to take time off uh, uh, for longer numbers. As time goes on, you're going to need more time for each number. So it's even less than 1,500,000,000 and 1,500,000,000 uh, as the maximum number for a lifetime. And it's even worse because in my family we live to be about 65, so I probably won't live. I probably won't see 70. So uh, um, that's even you know even worse. I probably won't even get to 700 million before I die, and then and then it's the obvious there's an obvious there's a next step to this that I'll get in a later video, but it's sufficient to say that if you counted your entire life, that whole thing where you say, well, I can give you I can just give you one number more than the one you gave me. Well, that'll go on until you die, and then at that point it's over. And like there's obvious retort that you will come up with, which I'll get into in the future video. But that was my explanation. And then I gave an extra example. I don't think he brought this up, but I added on an extra example, which was the computer. You know, if you if you know computer programming, you can set up a recursive function, uh, or supposedly infinite function where it just you know repeats and repeats and repeats and repeats, and you can say every time you repeat, you know, every time you repeat, you print the number on the screen, and then you count out one, and then you print the next number. So, doing that, you could get to, with a computer like mine, 1.9 gigahertz CPU and 6 gigs of RAM. You could probably count to a million in a second. Printing out the numbers one at a time. But there's limits to that. Also, uh, uh, there's limits to that also because if you if you if you had a computer and you say, okay, we're just gonna count up uh, on the computer, basically that computer has uh, uh, the computer will only be able to count up for so long. That's assuming certain other factors, which I'll get into later. But that computer will only be able to count up for so long. Think of all the computers that you've had in your lifetime. I've had a Gateway, a Compact, I believe I had one of the original Macintoshes, you know, but how long does each of those computers last? You know, it's got a shelf life of maybe, uh, I want to say 5 years. 5 years is like the maximum. So basically, you can count up a second, a million a second, and multiply that by 5 years. Uh, you know, and then the computer breaks down, and you know, and that's assuming certain other factors, which I'll get into later. But you know, uh, even with a computer, which can count much faster than a human, that's not infinity because at some point the computer is going to break down and it will have to stop at that point. So we will never experience infinity. We will never approach infinity. I mean, we don't. It, you know, it's not even it's not even a possibility to even we don't even understand what infinity is. Is infinity an unlimited supply of something, uh, uh, or is it you know is it an unlimited supply of one thing, or does it have to be an unlimited supply of everything, or we don't even we can't even wrap our minds around infinity because first of all, it's never been observed, it's never been recorded, it's never basically every time you see infinity in math, they either say well, it's infinity, but we're gonna cut it off at a certain number of decimal spaces, which is not infinity, or they're gonna say, we're just gonna say all infinity natural numbers, which is you're skipping all the numbers in between, which is not infinity. But I'll get into that in a later video. Basically, uh, so then another thing he said was uh, infinity is not practical. I was making my basically my argument is that infinity is not useful because it's not practical. It's not You can't come up with the right answer using infinity. You know, uh, so he says infinity is not practical. It's conceptual, which means that uh, it's for theory stuff, like on a chalkboard, and if you saw a movie A Beautiful Mind, it's for that kind of stuff, just messing around with math and figuring stuff out on paper. But I was like, uh, a conceptual list is even shorter than a physical list because concepts only last as long as you can remember them or for as long as it's written on the chalkboard. As soon as the next class comes into the university mathematics department and the next professor, erases that chalkboard, the concept is over. As soon as you know, get old or get distracted, or you're thinking about House of Cards on Netflix, you're not thinking about that concept anymore. Therefore, the concept is gone. So it has an even shorter lifespan than physically writing things out. I mean, there are books that, like the Bible, that have been around uh, since the first century. And there are books that have been around since the first century, uh, but you know, basically everything, all the concepts that were written down back in the first century or BC, 2000 BC, the only ones we remember are the ones that were written down. So written has a much longer shelf life than conceptual. And that's all I wanted to bring to you. Now I'll bring you the rest of the. It's a really long thing, so it's gonna probably be like 8 parts. But I'll bring you the rest later, and just think about infinity and whether or not you believe in it, and and have a nice day. Bye.